Welcome students. Today we will learn the application of dimension analysis. And first application is to check the consistency of an equation. Okay, consistency means correctness of equation, that whether the equation written is correct or not. So it works on the principle of homogeneity. Okay, what is the principle of homogeneity? Let us see. Like we have written V is equal to U. Okay, these are two physical quantities. V is final velocity, U is initial velocity. So we can equate initial and final velocity because both terms are dimensionally same. So it follows the principle of homogeneity, means this equal to sign is in mid. So LHS and RHS quantities are having same dimensions. So when we are going to check the consistency, we are just writing the dimensional formula of each quantities, and when we come on a result that all the quantities are having same dimension, then the equation is consistent or dimensionally correct. So let us take an example. V is equal to U plus 80. We are going to check this equation as it is dimensionally consistent or not. Okay, so what is the dimensional formula for V? It is LT minus 1. Please watch the first video of dimensional analysis part 1 to know in detail that how to calculate the dimension formula. Okay, U is also LT minus 1 because it is also velocity. Acceleration is LT minus 2 and time is T. So let us solve. LT minus 1 is equal to LT minus 1 plus, here when bases are same, powers are added in multiplication, so minus 2 and plus 1, it will become minus 1. So see here, all the quantities in LHS and RHS have same dimensional formula, therefore this equation is consistent. So with the help of dimensional analysis, we can check out that whether the equation is consistent or not, that is dimensionally correct or not. Only what you have to do, you have to apply principle of homogeneity. And how? By writing the dimensions of each quantities. Okay, by writing the dimensions of each quantity. Let us take another example, as V square is equal to U square plus 2S. So in this quantity, in this expression, we have to write the dimensional formula of each quantity. Okay, so let us see. We have to write the dimensional formula of each quantity. So V square means LT minus 1 square is equal to LT minus 1 square plus C. This 2 is having no dimension. 2 is a constant quantity. So dimensional analysis does not tell about the constant. This is the point, that via dimensional analysis we cannot think about this constant. Okay, this constant may be 3, 9, 11, doesn't matter, because equations will not change by these constant. But it is not physically correct if you are changing the constant. Means we can check only the consistency dimensionally, not physically. Okay, so we have not to write the dimensional formula of 2 because it have no dimensional formula, it is a constant. A is what? LT minus 2 and S is what? L. So let us see. Power, this 2 will be multiplied here. L2 T minus 2 is equal to L2 T minus 2 plus, here also L, here also L, 1 plus 1, it will become 2 and T minus 2. See here, again we are getting each side, that is LHS and RHS, the quantities are having same dimension formula, LT minus 2, L2 T minus 2, L2 T minus 2, L2 T minus 2, means this equation is also dimensionally correct. Therefore, in order to check the consistency, we have to apply principle of homogeneity, and just we have to write the LHS and RHS quantity with their dimensions. If the dimensions are coming same for each quantities, then we can say that the equation is dimensionally correct. Say I am telling dimensionally correct, not physically correct. It is not necessary that equation which is dimensionally correct is physically correct also, because we cannot determine the constants here. Okay class, so in the next lecture we will discuss some problem based on this application.